Week 6, coordinates and graphs. It's the last of our 6 basics. We've got 4 learning outcomes today. We're going to look at the conventions of coordinates, what we call things, how we plot them, how we read them. The second part of today will be looking at plotting basic equations. So on what we did last week, I gave you a heads up last week, where we substitute a value of x to get a value of y. We're going to use that to plot some lines. Okay, tomorrow we'll do this construction of linear functions and interpreting graphs. Essentially, once we've learned how to read and plot graphs, we're going to look at some very specific graphs, like conversion graphs and speed, distance, time graphs that tell stories. So let's kick off with some maths straight off. So things that we've done in the past, in previous lessons, that will impact today's lesson. So what's this all about? I've got -3 and I'm adding a -2. So what's the first thing that kicks in there that I have to deal with?
-3 and -2.
Yeah, I've got 2 negative numbers, but before I deal with those, I've got a sign confliction. So this is my sign rule, isn't it? And we've got a rule that deals with a positive and a negative, and it says the outcome of a positive and a negative is a negative. So if I'm rewriting this question, it's actually saying I've got -3, and I need to take away another 2. So we've gone from this confusing picture here to something we can now do on the number line. Remember how to do this on the number line? Yeah? On the number line, you're starting at -3, which is what that is telling me. This arrow, this minus sign is saying I'm going that direction, and this is telling me how many. So I end up at -5. So -3 plus -2 is -5. Because when you resolve the sign conflict, it's -3, -2. And when we visualize it in our heads, I'm starting at -3, I'm going in the negative direction, another 2. So I end up at -5. Yeah? The sooner you can start visualizing this, you don't have to write that number line down, the sooner you will get every single positive, negative numbers right when you're adding and subtracting them. So the second one is very much to do with what we did last week. So this is shorthand, this is our text speak. So in longhand, what does 2x plus 1 mean?
2 plus 1. Oh, in longhand.
Yeah, in longhand. So I've got 2x plus 1, so what does 2x mean? 2 times whatever my value for x is, plus 1. So straight away I've gone from shorthand to longhand so that I know what they want me to do with this. So now we do the substitution part. So it's saying, first of all, I want to put in the value of 3 for x. So quite literally, that's what you do. I've got 2 times 3 plus 1. What rule kicks in now? BIDMAS, and it's the 2 times 3. So it's 2 times 3 is 6, plus the 1, easy peasy, isn't it? Yeah? So when I put in 3, y is equal to 7, and that's how we plot graphs. Yeah, we're going to do that for 2 or 3 points and start plotting things today. So let's do it for -2. The reason I've chosen -2, I want you thinking about negative numbers, because if ever there was a place they can test your negative numbers, it's on coordinates and graphs. So let's have a look then. So I've still got 2 times x plus 1, but this time my x is -2. So when I rewrite it, I end up with 2 times -2 plus 1. So, BIDMAS still applies. What do I deal with first?
2 times 2.
Not 2 times 2, 2 times -2. So what's the outcome of 2 times -2?
-4.
Good. So our sign rule is signs. I've got a positive and a negative because I'm multiplying. I look at the signs in front of them. It's -4 plus 1. So now we're straight back to kind of the number line. I'm at -4. I'm going in the positive direction one. I end up at -3. Brilliant. So when I put in -2 for x, I end up with -3 for y. Can you see how that works? Yeah? So we're still breaking down the basics for you because coordinates and graphs are part of the basics. So, Pete's just landed from, I don't know, Mars. And I'm being told that we're doing coordinates today. What's a coordinate? Describe it. What does it do? What's involved with it? What's it all about?
Coordinates. Yeah.
Place setting, so it's a way of finding a place. And how do we do that? What's involved with it? How do I...
Across the bottom and across the top.
So what do we call the thing across the bottom?
Axis.
Which axis? is that one?
X and Y.
Yeah, which one's which?
The Y, X,
X
the Y
is
roll
always
across the bottom.
You're saying Y goes across what X?
I
X
say X.
goes across.
Oh yeah.
Okay? X goes across, Y uppy downy. And when you're giving a position, let's say I've got 1, 2, 3, 1, 2, 3, and I've got this point here that I want to plot, how do I describe that then as a coordinate? What comes first, the X or the Y?
Yeah, S.
X, so alphabetically X comes first, so it's 3 along, and then it's
2 up.
2 up. Does that look like a coordinate? What's missing? We've got 3 and 2.
Thing in the middle.
Thingy in the middle. What's the thingy in the middle? Comma. And what else is missing? Brackets. So when you give coordinates in mathematics, they have to be in brackets. You're telling everybody they're in brackets, and they have to have a comma to separate the X value from the Y value. So when you're giving a coordinate, you're going along the X direction first. Now at the moment we're going in a positive direction. So everything right of the Y-axis is positive, everything to the left is negative. So if I have a point here, they're still 1, 2 and 3, but they're minus 1, 2 and 3. Yeah? This is 1, 2 and 3, this is minus 1, minus 2. So can you see how the axes are labelled and worked? So quite realistically, if I chose a point down here, it's minus 2, minus 2. So the coordinate for this point is minus 2, minus 2. So you've got your x-axis first, so you decide whether you're going left or right. If you're going right, it's positive. If you're going left, it's negative x. And then you have to decide how many up or down. If it's up, it's positive. If it's down, it's negative. Okay? So that's basic coordinates and how you read them. So you're expected to do 2 things with coordinates. Either plot them when you're given one, or read one that you've been given. So if I put a little cross, I don't know, there, and we call that A, the question will say something along the lines of, what's the coordinates of A?
5, 2 in brackets.
5, 2, all in brackets. Perfect. Yeah, that's your mark. And it is as straightforward as that. Okay? However, they might say, plot the point B at position minus 3, 2. So you've now got to do the plotting. So you've done the reading, you're now expected to put something on to that grid. So where does it live? It's positive. The golden shots. Yes. So this one is saying go 3 left and 2 up. Okay.
X first. and
X
Y.
first, yeah. Alphabetically as well. X comes before Y. So some people at school learn alphabetically X and Y, always in brackets, always separated by a comma. Okay, that's your format. So you go across and then up and down. There was some kind of saying about in the houses and up the stairs. There is one point that I haven't mentioned on that last one, something that they do talk about. This point in the middle, what's the coordinates for it?
0, 0.
0, 0. It's a very special one because it's the only thing on there that's got a name. Do you know what you call that? The centre of a graph. It's the origin. Okay? The origin. So they might say plot a line from the origin to point 2, 4. If you don't know what the origin means, you can't plot that line. You can have a guess, I suppose, but it's one of our buzzwords. If you don't know the word, you can't answer the question. Okay? So the centre here is called the origin. So, no point messing around. I'll get you to plot some coordinates and read some coordinates off a worksheet. Okay? So you only get good at this sort of stuff by doing them. Just do the. What we're going to do now is we're going to move on to the next bit of this, the logical progression, which is when we plot 2 points like we've just been doing. So if we plot a point here and we plot a point here, the natural progression when you have 2 points on a graph is to join them. So now we're creating lines on graphs. So you've just been doing points on graphs up to now. When you join the points, you create not a line, but this is very specific, okay? And it's one of our buzzwords. It's called a line segment, okay? So if they ask for a line segment in the exam, they're not asking you to draw a line from infinity and beyond, they're asking you to join 2 points. Okay? So a line segment isn't a complete line that goes off to infinity in both directions. A line segment just merely joins your 2 points that you've been asked to plot. So what they might get you to do is they might give you point A, let's call this point A. They might get you to plot point B, so they'll get you to read the coordinates of point A. They'll get you to plot point B. They'll then ask you to join the 2 as a line segment, in other words, draw the line between them, and then comes the nasty stuff. And they'll ask you to do something called a midpoint of a line segment. Do not panic, lots of fancy words. All they're saying is, what's my halfway point between A and B? And there's 2 or 3 different ways of doing it. There's an easy way, there's a really easy way, and then of course there's the maths way. So let's do the easy ways first. What's the easiest way of finding that halfway point? Get a ruler. Get a ruler and say, oh, that's halfway. Nothing wrong with that at all. There's another way of doing the same thing but slightly differently. In mathematics, to find a midpoint when you've got a diagram and you can count the distance, you can go 1, 2, 3, it's 4 along, and it's 1, 2, 3, 4 up. So if I halve them, if I go 2 along and 2 up, I end up at my midpoint. Can you see what I've done there? So again, visually, I can do it really quickly, just halve my distances. Does that make sense? Nice and easy so far. Let's do it the maths way. So point A is at 2, 1. Point B is at 6, 5. So they're the 2 points I'm connecting. By drawing our midpoint, I can see that my midpoint is at 4, 3. Can everyone see that? So can you see mathematically what I need to do to get from 2 and 6 to 4, 1 and 5 to get 3?
Minus the 2 off the 6 and the 5, the 1 off the...
Ooh, close, close.
Divide.
You divide.
6 by 2.
Yeah, and
5 by 1.
you add them together and then divide.
Right.
So if I add 6 and 2, I end up with 8. Divide it by 2 because I've added 2 things together and I'm looking for the average. I end up with 4. I add 1 and 5, I get 6.
Yes.
Divide it by 2, it gives me my 3. Can you see what we've done mathematically? So if you add your x coordinates together and divide by 2, it gives you the midpoint x coordinate. If you add your 2 y coordinates together and divide by 2, it gives you your midpoint y coordinate. It's not magic, it's just what you're doing in your heads here. So you've got your 2 very visual ways, but you've also got a mathematical way. And sometimes in the exam, they might not give you the question on a visual representation. They will just say, what is the midpoint between this and that? And what they're trying to force you to do is the mathematical way. Okay? So this is what we've just talked about, but a lot more wordy. To find out that midpoint, all we need to do is add our 2 x coordinates, 2 and 6, to get 8, divide it by 2, and it tells me it's 4. Okay. There's another example. The other type of question they can give you is where they give you one of the points on the line segment and the midpoint, and you're expected to find the other end of the line segment. Okay? So here I've got the start of my line, and I've got the midpoint of my line, so I need to find out where the end of my line is. So all you do is exactly what we did in the previous slide. You count 1, 2 along, 2 up. So all you need to do is go 2 along and 2 up. So point B is the other end of my line segment. Can you see what I've done there? Yeah. If you wanted to do it in a mathematical way, I'm at point 1, 2, and my midpoint is at 3, 4. So to find where the line ends, slightly different this time, what have I done to get from 1 to 3? I've added 2. So if I add another 2, it tells me that 5 is my x-coordinate. What have I done to get from 2 to 4? I've added 2, add another 2, and I end up at a y-coordinate of 6. So my other end of my line is at 5, 6. When we have positive numbers, it's nice and straightforward. If I've got 3, 2, and I plot it against 9, 6, okay, whether I do it visually or wherever, I can see where the midpoint is. If I do it mathematically, I've got 12 divided by 2 gives me 6, and then 6 plus 2 is 8, divided by 2 is 4. So my midpoint of 3, 2 and 9, 6, 3, 2 and 9, 6, if I did it mathematically, would be 6, 4, 6, 4. That's my midpoint. So my maths works. Yeah? So I've done it visually, I can see it, or I can do it mathematically. Now when people start trying to do it mathematically with negative coordinates, they start going all over the place, okay? So let's just choose a really nasty negative coordinate. I've got minus 2, 2, which is the start of my line segment, and I've got minus 10, 4. Okay? So that's my line. What is the midpoint of my line? I could do it visually, I could draw the line and work out where the middle is, or I can use the maths, but the maths suddenly comes slightly harder because we've got these negative numbers. If I've got minus 10 and I add minus 2 and minus 10, what do I get?
Minus 12.
Good. Remember when we started the lesson, the smart recap? Minus 2 plus minus 3 is minus 5. Minus 2 plus minus 10. Let's do the maths for that. I've got minus 2 and I want to add minus 10. What's the outcome of my confliction here? Minus, so I've got minus 2 minus 10. I start at minus 2. The minus sign is go left, and I go left another 10, which takes me to minus 12. So I've got minus 12, I divide by 2, and I end up with minus 6 as my x-coordinate. My y-coordinate's nice and easy. 4 plus 2 is 6, divide by 2 is 3. So my midpoint is minus 6, 1, 2, 3. Yeah? See how it works with negative numbers. So now if you have a look at your worksheet, because they introduce negative numbers really quickly on your worksheet, you'll be able to calculate the midpoints either mathematically or by diagrams. So try a bit of both on that worksheet. So that's the first part of the lesson done. What we're going to look at now is drawing straight line graphs, linear graphs. Graphs are straight lines in maths, okay, extend from one corner of the diagram to the other. So on a line segment, we talked about plotting between 2 points, and we stop the line on those 2 points. When you get a question that says plot the graph or plot the line for this equation, you have to draw it from one edge to the other, because what they'll do is they'll give you 2 or 3 points to plot, and I'll do the same for you, and by natural instinct you'll just draw between those 2 points. You won't extend them all the way to the ends. So when they're asking you to draw these line graphs and graphs, they go to the ends. The only time you don't draw them to the ends is when you see the word line segment. Okay? So, a linear graph is a straight line graph. And it's a straight line in mathematics for a reason. When we define graphs in maths, we tend to use x and y because we have x and y axes. So you'll see a lot of graphs in mathematics that look like this: y equals x, or y equals 2x plus 2, or something like that, okay? The reason they draw a straight line every time is because x has an invisible power of 1 that we don't write. Just like we don't write x is positive, or x is being divided by 1. All these things happening to x we don't write. So x has a power of 1. So anything that has a power of 1, in other words just the letter on its own, will draw you a straight line graph. Now today we're concentrating on x and y's because that's how we come across graphs. Tomorrow you will see that we don't have to use just x and y. We could use a and b, or c and d. For example, in your assignment that I'm going to give you, there might be a graph that says the cost of hiring a mountain bike is £2 a day, 2d, plus a £4 deposit up front. So don't get it into your head that x and y's are the only way to plot the graphs. There could be other letters that represent things like the cost or the number of days, or, you know, pounds, or whatever it might be. So how do we plot these linear graphs? There's two main ways. The first way is that we need to plot some values for x, like we practiced last week, where we have a value that we're given and we put it into the equation and it gives us a value for y, like we did with our smart startup at the beginning of the lesson. How many points do you think we need to draw a straight line? What's a good number of points to plot to get a straight line? So generally, when you plot a straight line and you're doing it the substitute method, you put 3 values in. And the reason you put 3 values in is if they ain't on the straight line, you've done a calculation wrong. Okay? So when we're doing these calculations, generally they will make you plot 3 points as a minimum. Because if you plot 3 points, you can't make any mistakes. They have to be on that straight line. Okay? So what we're going to practice next is swapping values into equations so that we can plot these lines. And we were doing this last week. We're going to start off with the easiest one on the planet because nothing is being done to x. Y equals x. Nice and straightforward. So when x has a value of 1, I put the value of 1 in here. Guess what the value of y is?
1.
And when I put 2 into that, y has a value of
4.
And when I put 3 into there, y has a value of 3. Okay? So this is a pretty special graph, this one. Okay, and we'll come on to it a bit later, where I plot 1, 1, 2, 2 and 3, 3. I get a lovely diagonal line that looks like that. Notice I start at the top and I finish at the bottom of the diagram because I'm plotting a line. I'm not plotting a segment between the 3 points that I've just written down. Okay? So that is what is involved with plotting graphs. You put in values for x, it gives you the value for y, you go to your graph, you put your crosses down, and then you draw your line to plot your graph. Okay? So let's look at something slightly more complicated, like we did at the start of the lesson. Okay? I've got y equals 2x plus 2. So those of us last week who were here, what does 2x plus 2 mean in maths? 2 times whatever the value of x is, plus 2. Everyone remember that from last week. That's what that means. So now, all I'm going to do is swap this x here for various values. So let's try it with 0. I put 0 there, and big maths tells me I've got to do the multiplication first. What's 2 times 0? 0, good. Plus 2, so 0 plus 2 is 2. Let's put a value of 1 in there. I swap x for 1, I have 2 times 1. 2, add another 2. I put the value of 2 in there. 2 times 2, 4, plus the 2, good. I go to my graph, cunningly prepared beforehand, and I go 0, 2, 1, 4, 2, 6, about as straight as I can do freehand, from the edge of the graph to the edge of the graph, not just through those 3 points, because they're points that I might have made up, okay? So can you see how to plot graphs? You happy with that?
Yeah.
Okay, let's have a go then. There are some special line graphs out there. These line graphs we've come across already. Y equals x is a special one that you will need to recognise. It's that diagonal line that goes at 45 degrees across a bit. We're going to plot it in a second, don't worry. But you might come across these to either plot or describe. In other words, they'll give you a line that you need to describe. And these special graphs can be y equals a value, for example, y equals -2, or x equals a value, like x equals 3. Okay? So what we're going to do next, for the next 10 minutes, is I'm going to describe these special types of graphs to you. We're going to plot them and show you why they draw particular lines, and then you've got the second half of the worksheet to work on them. Okay? So let's have a look at this first one, y equals x. We did it earlier. When x is 1, what's y?
1.
And 2, 2, 3, 3. So when we go to our graph and we plot it, Pete's really accurate line drawing, you end up with that diagonal line. That's quite important because what we're doing today covers units 1, 2 and 3. And when you get to unit 3, they love using this diagonal line as a line of reflection when you're reflecting shades. And they will ask you to describe that line. So the way you describe a line that goes diagonally that way is x equals y. So kind of log that into your brains. When you get these diagonal lines, like that. That's x equals y. Let me show you another one that's one of their favourites, okay? Linked with that. This is y equals minus x. So when I stick the number 1 in for x, what is y?
-1.
Minus 1. Can everyone see that? So when I swap x for the number 1, it becomes minus 1, doesn't it?
Yeah.
So x is 1, y is minus 1. When x is 2, y is minus 2. When x is 3, y is minus 3. Let's plot this one. When x is 1, y is minus 1. When x is 2, y is minus 2. When x is 3, y is minus 3. So their other favourite line is one that goes in the other diagonal. And they might say, this is a line of reflection, you've got a shape, you've reflected the shape, don't worry about that, we'll do that come March time. But they will say, describe the line of reflection. And the way you describe it is y equals minus x. So if it slopes that way, it's y equals x. If it slopes that way, it's y equals minus x. This will mean more to you when you've watched the YouTube video on gradients, okay, which we'll come to in a minute. Everybody happy with y equals x and y equals minus x? Okay. Let's move on then. Let's talk about x having a value of something, okay? So you might get asked to plot it or describe it. So you need to go both ways with this. So if x equals 6, what's my value for x?
6.
And
12. Yes, 6.
so it's telling me, I don't care what I've got for y, x has to be 6. So let's plot it. What shall I use for y?
0.
Let's just pick 3 random values. It doesn't matter what y is, as long as x is 6. Let's plot this. X is 6, y is 0. X is 6, y is 1. X is 6, y is 2. Lo and behold, when x equals a value, you get a vertical line. Okay? So this is another thing they like to test you on. They'll say a line of reflection and x equals a value describes that. And it's x equals whichever value it cuts through. Here, it cuts through 6. So if we did the same here, x equals minus 2, what are my y values?
Anything?
Don't care. Right? I go 0, minus 2, I've got, sorry, wrong way round. Minus 2, 0, I've got minus 2, 1, and I've got minus 2, 2. So can you see, when x equals a value, what it draws is a vertical line through that number. Yeah? Does that make sense? Okay. So, they might get you to do something in Unit 3. And they might say, oh, I've got a square here, and I've got a, 1, 2, 3, 4, I've got a square there. Draw the line of reflection, and you'll go, oh, that's the line of reflection, that's what I reflect this in. They'll then say, and describe that line. So if I was describing that line in the exam for my 1 mark, it would be what?
X equals 1.
Because it goes through the value of 1. It's a vertical line, and it goes through the value of 1. Yeah? So when we get on to reflection in a few weeks' time, the line of reflection is the halfway point between the two shapes, which is this line here. So they will then say, what is your line of reflection? And your line of reflection is this value, x equals 1. So vertical lines are described by x equals a value. Guess what we're going to do next?
Y.
And what do you think y draws?
A horizontal line.
Horizontal line. So if we do that, what's y equal to?
4.
What's x equal to? Don't care. So let's plot it. When x is 0, y is 4. When x is 1, y is 4. When x is 2, y is 4. When I join my 3 points, lo and behold, I have a horizontal line that cuts through the value of 4. Yeah? Makes sense? Your opinion? Okay. So what do you think is going to happen? Y equals minus 1.
Minus 1.
Minus 1, minus 1, minus 1. And when I come to plot it, what am I going to end up on here?
A horizontal line.
A horizontal line through minus 1. How can it work the other way? They can say, you've done something with a shape, and this is the line of reflection. Describe that line of reflection. So the line of reflection is y equals 2. Can you see how that works? So horizontal lines, it's y equals the value. Vertical lines, x equals the value. Okay, don't forget your x equals y and your x equals minus y. So if you flip your papers over, there are questions 5 and 6 are the special types of lines. Question 7 is a nasty, and question 8 is just that negative x thing. What we're going to do now is we're going to have a really quick 45 minutes on some. Right, so what we're going to do now is we're going to concentrate on 2 sets of graphs. The first set of graphs are what we call conversion graphs. Conversion graphs allow us to change things rapidly. Now, we already have covered something in this course that changes something for you, and that's called a ratio. So a ratio, when we talk about ratios, we could change things from, say, miles to kilometres. So we know there are 5 miles to 8 kilometres. So if you're like me and you're on running machines in the gym and they're all in kilometres, I'm old-fashioned, I work in miles, so I'm always converting things backwards from kilometres into miles in my head. And the way you used to do it, or you would have done it up to now, is using a ratio, because that's all a ratio is. When we talk about miles in kilometres, 5 miles to 8 kilometres, if I said I got on the running machine and I ran 16 kilometres, it's a ratio. All I've done is gone from 8 to 16, so I've times it by 2. So all I would do over here is times it by 2, and I would have 10 miles. So 16 kilometres is 10 miles. So can you see how that works for ratios? Well, there could be instances where you want to look up lots and lots of changes. Maybe you're in a travel agency and you're changing money constantly. You're in a gym and you don't know how far you're going to run, so you don't want to use hard sums in maths. You might want to just go to a graph and look it up, okay? And that's quite easy to prepare the graph that you do the looking up. All you need to do is pick 3 values. It's just like plotting our straight line graph, okay? Pick 3 values that are dead easy to do. Well, I've got my first value when 5 miles I know is 8 kilometres. That's my first one I can plot. I've just picked a really easy one here. I know that 10 miles is 16 kilometres. I also know if I've run no distance, 0 miles is 0 kilometres. So I've got 3 points there that if I take to a graph, I can go 0 miles is 0 kilometres. I know 5 miles is 6, 7, 8 kilometres, and I know that 10 miles is 16 kilometres. Lo and behold, I join my crosses and it's the perfect straight line. Okay? So what that allows me to do now is I can go to this graph when I get off the running machine having run, 7 miles, and say how many kilometres did I do? Okay, so I go 7 miles, lo and behold it's just over 10 clicks. Yeah? If I'm on the running machine and it says, oh well, you've run 8 kilometres today. Go to 8 kilometres, go down, oh it's 5 miles, well I know that one anyway. But can you see how it's more useful? So just by knowing 3 basic points, you can plot a straight line graph that then allows you to go to it and read the information off for anything, any value, without getting that headache trying to do ratios all the time or trying to do hard sums. You just draw a graph and then you plot everything from that graph. Does that make sense? Yeah? So that's what conversion graphs are, and you are quite likely to get conversion graphs. They're quite keen on these, okay, because they are so useful. So here you go, just an example of what I've just drawn. We've plotted our graph, and they'll say to you, oh, Joe Bloggs in his car went 60 kilometres, how many miles? So you're just reading a graph, miles against kilometres, and you just hit the line and read straight down, okay? Not going to teach you to suck eggs, that's nice and straightforward. What I'd like you to do is do a conversion graph for me and give me some values. So you're working in a travel agent, let's say, and I want you to plot a currency graph for pounds to yen. Just to show you how they'll ask you the questions, it's the kind of exchange rate questions where John goes off and buys a camera, and in Florida it's $360, and in Manchester Airport before he goes it's 250 quid. Where should he buy it from? And all they're getting you to do is say, well, I know my scale doesn't go up to $360, so I can actually look up 36 and multiply whatever the pounds is by 10. Yeah? So sometimes they'll give you something that isn't on your graph, so you have to scale it down. So here they wanted to look up $360, their scale only goes up to 60. So what they've cleverly done is they've said, rather than look up 360, I'll look up 36. It gives me £22, but you have to remember I divided it by 10, so I need to multiply it by 10 to give me the £220. so he's actually better off buying it in Florida. Okay, these conversions that you use for everything. If you're like me, you're old-fashioned, you talk about miles per gallon on your car. I don't do the litres thing. Or when I'm filling up my car and it says 35 litres, that doesn't mean anything to me. I'm old-fashioned. I used to fill up my car and I used to know it was like 8 and a bit gallons. Yeah. So you'll see these things everywhere. So the reason I'm putting all these different things up is in the exam it can give you anything. All they are a visual representation of a ratio. There's a relationship between a litre and a gallon that we'll come on to in Unit 3, okay? And it just allows you to look things up quickly rather than working things out in ratios. So that's the thing with them, okay? Sorts of questions they can ask you. Petrol tank holds 8 gallons, how many litres is this? So you go to 8 gallons, you go up, and it's just over 35 litres, okay? Everyone happy with reading off the axes on a graph? I won't do that one to death, okay? So everyone happy with our first type of graph, which are our conversion graphs. Straight line graphs that change a ratio into something visual that you can just go to any value and look up. Good. Okay, the next bit's going to be really quick as well. Distance time graphs. Distance time graphs are different and they're really keen on them. They're in almost every paper. And the reason they're different is that it's not just a straight line. The graph for a distance speed time graph tells a story. Now we'll deal with distance, speed, time calculations in a few weeks. Because we're talking about graphs at the moment, I wanted to strike while the iron was hot. And these distance, speed, time graphs tell you a story, and they do certain things. Anybody tell me about what's going on there? I've got this shape that goes like this and along.
Where it's going straight, that's where it stops.
Good.
It's not moving.
So if you get anything that's horizontal, he's stopped.
The upwards lines is him accelerating or increasing.
Yeah, so this shows acceleration, that shows his speed. He's doing a certain amount of distance in a certain amount of
The line
time.
going down is saying he's going backwards.
Good. So he's going away when it's going up, and then when he's coming down this way, he's coming back towards wherever he started off. And you know he's got back to where he started because the distance from where he started is 0. So that's him returning home. Okay? So little horizontal things like that are stops. So when it's horizontal, it's stopping. When it's going like that, he's going away from where he started. When it's coming down the way, he's coming back to where he set off from. What about the line, when it's like that and like that? What do they tell us? The steepness of the line, what's that all about?
It's showing how fast he's going.
Yeah.
So is it distance divided by time?
Yeah.
Speed, yeah.
So basically, the steeper the line, the faster he's going because he's doing more distance over less time. Yeah. So the steepness of the line actually tells you something as well. It tells you his speed because it's distance divided by the time. So in theory, when it starts going like that, he's doing more distance over less time. Therefore, he's going faster and faster. When it starts going like that, it's getting slower, 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 slower. Stop. Yeah. So that's the way to look at those. And they'll ask you questions. They won't ask you about the gradients per se, but they will ask you what's happening here as opposed to what's happening there. Well, he's going reasonably fast there, but he speeds up there because the line's gone steeper. Yeah. And that's the kind of question you'll get at this level. Okay. So the things it talks about, when the line's going up, you're going away from where you started. When it's horizontal, you're stationary. When it's going down, you're returning to where you set up from. And then the steeper the line, the faster you're going because you're doing more distance in less time. Okay. And there's all sorts of things. It doesn't have to be a car, it can be you walking. In this case, it can be a bicycle. Okay, Harry went for a ride. After he got a puncture, he stopped to fix it. And they can ask you anything about this. What time did he set off? How far did he go before he stopped with his puncture? How long did he stop with his puncture? Now, the trick with these graphs is this. This is where they'll try and trap you. And it's the division of time. Now, time isn't like the number system that we use in groups of 10. In time, we talk about groups of 60. It goes all the way back to the Babylonians who used a factor of 60. So the thing to remember is decimal time. Now here it's nice and in bits. You've got 1, 2, 3, 4 divisions, so you know each division is 15 minutes. Yeah? So you know halfway between, but it isn't, because that's 30 minutes. you've got 4 divisions that cuts up 30 minutes. So you've got 30 minutes divided into 4. 4 doesn't go into 3, 4 goes into 30, 7 times, remainder 2, 7 goes into that, 7, 14, 4 goes into that 5 times. So each one of those divisions is 7.5 minutes. And this is how they catch you out at GCSE foundation level with speed, distance, time graphs. There's always going to be a question to do with the time. I saw, what's 0.1 of a minute? We're close. What's 0.1 of a minute? If you've got 60 seconds in a minute and I divide it into 10, because that's what decimal is, so what's 1.1 of a minute? What's 60 divided by 10? 6. So 0.1 of a minute is 6 seconds. What I'm saying is, speed, distance, time graphs are really easy to read, and a lot of you will get the easy marks to do that. Where you'll drop marks is because people don't understand the time divisions here, and you have to think in multiples of 60 when you're talking about time. Okay, let's get rid of that one. So we're talking about Henry's bike ride, and they'll ask you questions like, what time did he leave home? 8:15. So can you read the timeline? They'll say, how far did he get before he got his puncture? Well, he obviously had to stop for his puncture, so you have to go down and read your time for that. Okay, 8:45. What was his speed after the puncture? We'll teach you about how to do speeds later. Okay, so really these speed, distance, time graphs tell a story. They can ask you questions about how fast he's going, where did he stop, what time did he get home, okay, generally on that timeline. Now, these questions don't have to be just about speed. This one came up a while back, and it's about a lemonade vat filling. You know, these industrial big silver vat things, okay? And it's a speed, distance, time graph, but it's the speed that the lemonade tank was filling, okay? But it tells the same story. At 9 in the morning, the tank was empty, okay? By 10 o'clock, they did something. What did they do at 10 o'clock?
Change the rate of how much?
Faster or slower?
Slower.
Good. So here they're filling the tank at quite a fast rate. At 10 o'clock it then starts flat, it goes slower. Don't forget flat is stopped, so it's getting slower. Okay. Then they stopped filling the tank when it got to about 2.5 meters high on the gauge on the side of the tank. And then at 11:30 they then started emptying the tank until by 1 o'clock the tank was empty. So the stories don't have to be about speed, distance, time. They can be about wacky things like filling lemonade tanks up, but they'll still have time against a rate of something, the rate of flow, okay? Good. Another type of graph that fits into this telling a story are graphs where you have like mobile phone hire or bicycle hire or things like that. And this is an example of like an online game where for 15 quid you get 23 games online. But once you've played your 23 games, you then have to start paying for every game afterwards. And what they're saying here is that for every 20 games you play, it's going to cost you another £25. Okay? So you have to be really able to read things like this. Now the examples of these have included mobile phone hire, hiring a lawyer, hiring a motorbike or a bicycle. I've got this one here, which is to do with buying online games. And they tell a story. They're not just straight line graphs, that's a bit of a story. In other words, I get 20 games free, but when I hit the 20 game mark, I then have to start paying for my games. And they can ask you questions about these as well. Okay? So here's another example of this telling a story. So not just straight line graphs now, talking about graphs that tell stories. I've got 2 cars, A and B, and they're covering a distance over a set number of time. Car A is the solid black line, car B is the dotted line. Now this is quite important because when you get to your exam, it's in black and white. So the only way they can give you graphs with 2 lines on is a thick line and a dotted line. So make sure you're talking about the right one, okay? So here they're going to ask you, at what time did car A overtake car B? So the story we're saying is, the dotted line is car B and he shot off quicker and he got ahead. And at this point here, car A then overtook him, okay? So what they're asking for is, at 3 p.m, car A overtook car B. So another question to do with this graph, okay? It could be, when car A stopped at 2 o'clock, how far ahead was car B? So car A stopped at 2 o'clock, car B was 20 miles, 2 divisions higher. These are the sorts of questions they ask. These diagrams tell a story. You need to be able to read the story and answer the questions on that story. Okay? That's the questions that I've just asked you. Everyone happy with speed, distance, time graphs?
Yeah.
You get lots of practice in the assignment, which I'll give you in a second. In fact, I'll give it to you now. So as far as we're concerned with coordinates and graphs, it's not a huge amount because we do the trickier stuff with graphs a bit later when you come back after half term.